In this nugget, we're going to investigate some methods and tools that we can use to identify malicious software that's running on our systems. I'd like to start off with a question. Let's assume that you and I are sitting at a computer and it starts to act slow, or certain keys on the keyboard don't work, and we reboot it and it still is having problems, and we suspect that there's a virus or a trojan installed. What would we do? Give that a moment. Let's think about that. What would we do? Well, if it was me, it's very likely I would probably download or get an updated version of the antivirus or anti-malware software and give the computer a good scan. And some anti-malware software is looking for signatures or matching on hashes, while other software is looking for how applications are behaving, or perhaps have built a baseline of what normal looks like on a computer or system, and then when traffic or behaviors go beyond that, they start firing off the bells and whistles. But in any case, in our example, let's say that none of those caught the virus or caught the malware that's on our system. What do we do next? Well, here's a laundry list right here of items that we could look for regarding suspicious activity. And it starts off with ports on our computer. If we have ports that are unused and simply open on strange port numbers, listening, that could be an indication of a virus or a trojan installed. So if we saw, for example, port 6666 as a listening port on our local computer, what we could do is we could Google and search for port 6666 and see if there's any well-known applications, including malware, that are using that on the victim's machine to allow the attacker to initiate a connection over to that device. Besides unused ports that are listening, we could also look for established connections that seem odd. For example, from our computer to a remote device on some port or service that we don't recognize. And some tools that we could use on a Windows computer to look at ports would include netstat, which is built into Windows. There's also an application that's written by sysinternals called TCPview, which can show you that information. And there's also an application called curports, which is another host-based type monitoring application that can show us the currently open TCP and UDP ports on our local system. And to make it interesting, let's go ahead and establish a connection from this Windows 10 computer to the hacker's system so we can see what that looks like in our monitoring tools. So if we open up the file system with File Explorer and we go to the C drive, we have a folder called hack, and through the course of these nuggets together, we've created a file called fun.txt.bat. We created it as part of the social engineering toolkit. And what this does when launched, it allows a connection to be established from this computer over to our Kali Linux box. So let's go ahead and launch that. And I also have Kali Linux set up on the other side to receive that connection. And now let's take a look at some tools we can use to look at our connections. The first one I'd like to demonstrate is netstat. So let's click on the Windows icon in the bottom left-hand corner. We'll type in CMD, and then we'll right-click on the command prompt and say Run as Administrator. We'll say yes to the user account control. And from here, let's type in netstat space, let's do a slash question mark, and that will show us our help. So there's lots of options here in netstat. A couple I'd like to point out right here for us. One is -A to display all connections and listening ports, and -N, which is just going to show us the port numbers in numerical form. So let's do that together. Let's type in netstat space -A space -N and press enter. Now there's a lot of output there. And I also see a boatload of IPv6, which in a secure environment, if we're not using IPv6, we should go ahead and remove it from the protocol stack on our local computer. In fact, let me do that right now on this Windows 10 computer. I'm going to right-click on the networking icon in the bottom right-hand corner, click on Open Network and Sharing Center. This is one way of getting there. Over here on the left, click on Change Adapter Settings, then right-click on the network adapter, and from the drop-down, go to Properties, and then scroll down to IPv6 and remove the check from that checkbox so IPv6 is not enabled, and we'll click on OK. We've just reduced the attack vector on this computer because we're no longer running IPv6, which in my lab environment is okay because I'm not using IPv6, at least on this computer right now in the lab. So I'll go ahead and close Control Panel, and then we'll hit the up arrow key to run netstat-A-N again. So if we scroll to the top of this output, it would appear that this Windows 10 machine has not yet let go of all of its IPv6 information, but that's okay. We'll focus on our IPv4, and we'll continue to scroll up. So there's a lot of TCP ports here that this computer is listening on, and if we didn't recognize these or wanted to do Google searches on those port numbers, we could look those up. We might also ask, okay, why is this guy listening on port 80? Which implies that we're running some type of a web service, which could be possible because we've installed a lot of utilities, including SolarWinds and so forth, that may be using a graphical user interface for the management of this system. So let's continue down. And look at this guy right here. This is the guy that looks a little bit fishy to me. And the reason it looks fishy to me is because I know what the IP address is of the attacker machine. It's 192.168.1.109. We're connecting on port 443, which looks okay because it looks like SSL/TLS, which is secure web services. However, what that really is, that's the connection over to our attacker machine. So regarding our connections, we could do a reverse lookup on the IP addresses to see what part of the world those IP addresses are associated with. If we had port numbers that we didn't recognize, we could search on those as well to help identify suspicious connections that we might have on our system. So the other tools I mentioned besides netstat would include TCPview, curports, and I'm sure there's many others that can help us get a picture of our existing connections on our local machine. We'd also want to take a look at what processes are running on our computer. Do we recognize or can we establish a reason for each of them being there? And some tools that we could use include Task Manager, which is built into Windows. So here's an example of Process Monitor from sysinternals. And by default, it has showing everything. And if we want to filter some of the information, we can turn off, for example, registry activity, and we'll apply that filter. Then we can take a look at one, for example, this one right here. We can scroll all the way right. So if we see something in the detail that looks a little bit off or wacky, or that it's not like playing by the rules, that could be a process that we might want to look into. And as we scroll up, it has additional detail about the executable and the DLL involved regarding that process. Also has the process ID if we wanted to look that up, for example, in Task Manager. Another nook and cranny to look in is specifically in the registry entries. Now, because the registry is so big, we're probably going to want some tools that can assist us in looking for anomalies or suspicious activity in the registry. So there are several sets of power tools that are out there, including one called JV16. There's a tool called Reg Scanner. So the key is I would like to remind you that when you're looking for a registry scanner, make sure you're dealing with a product that, one, doesn't have a Trojan itself that's putting on your system, and two, get one that's highly rated regarding your peers. So I love Reddit. If you want to do a search of Reddit for the scanner you're looking at, you'll often get a lot of really great, honest feedback through Reddit regarding people's experience, both good and bad, with that product. Here's an example of JV16 power tools. So from the home button, we have several options, including controlling which programs start automatically. There's some options for immunization and protection. And if we go to registry tools, for example, there's a registry monitor that we can use, a registry cleaner that we can use, and click on the control which programs start automatically. And let me maximize this a little bit. And this is pretty cool because here with the Java updater highlighted right here, it specifies where that file is coming from and also where in the registry it's being pulled from, which is HKey, local machine, software, etc., etc. So if we didn't want that to run, for example, I don't really need the Java updater anyway, so we can go ahead and click on the checkbox for that application, click on disable down here near the bottom right. So now with the registry change we just made, that'll be no longer part of our startup when this machine boots. Also, I probably don't need proxy switcher anymore from one of our earlier nuggets, so I'm going to select that and disable that as well. And if we wanted to remove it altogether, we could select it and then go ahead and click on delete. So this is one of many applications that can help us manage and work with the registry entries on our Windows computers. Another item we might want to check are our device drivers. And that's because malware, once it's downloaded and installed, sometimes it'll be hidden as a device driver to avoid detection. So we want to make sure we know, first of all, what the device drivers are that are running on our system. We'd also want to verify that they are legitimate device drivers from trusted sources. One way of taking a closer look at our device drivers is to click on the Windows icon here on Windows 10, type in msinfo, and press enter. So showing us the system summary by default, we'll expand the software environment by clicking on the plus symbol next to that, and then we can select system drivers to look at the device drivers installed. So we could scroll through this list looking for anything that looks, for example, out of sorts. And one of the things that might be a tip-off is if we have a file that's coming from some wacky location that seems abnormal. Because the malware that was installed may not have the rights to that same location in the file system, so they had to put it somewhere else. Another tool among many that are out there is called Driver View. If we click on Help and go to About with Driver View, it gives us information regarding the creator and the website for that creator. And one thing I like about Driver View is that we can hide the drivers that are non-Microsoft. For example, if we know that all the Microsoft drivers are okay and we're looking for everything else, we can go under View, and then we can select the option to hide Microsoft drivers. And now we're just looking at the drivers on this system that are non-Microsoft. Another thing we'd want to take a look at are the services that are running on our system. Because malware, including Trojans, can spawn a Windows service which can then run, which allows the attacker to get remote access or to compromise that system. And a lot of times malware will rename the process to look like a genuine Windows application or service in order to avoid detection. Now, we may use native tools to look at the services running, or a third-party tool like this one called Service Manager. And if we click on Help with Service Manager and go to About, it's distributed by www.sysprogs.org. And again, this is just one of many examples of a tool that we could use to help analyze services that are running. So if we scroll down and grab a service, for example, the SolarWinds alerting service, it shows that it's running. It shows the start type is auto. And then from right here, if we wanted to modify or change that, we have tools as well. We could stop the service down here at the bottom, delete the service, restart the service, or if we want to look at properties of that service, it could give us details on that service. Another way of looking at our services, of course, would be to click on the Windows icon here on Windows 10 in the bottom left-hand corner, type in MS Info once again, and then here in System Information under Software Environment, selecting Services, and that'll also give us a list of our services on this Windows computer. Now, because there are several different locations and ways that applications can be started up on a Windows computer, it's handy to have an app to kind of give us a bird's eye view of that. And one of those tools is called Security Auto Run. And what Security Auto Run does, it displays all of the applications that are loaded automatically when Windows starts up. So here is Security Auto Run. Let's click on the question mark in the upper right-hand corner to provide a shout out for the individual who created this. And here's a website, tcpmonitor.altervista.org, that has a lot of additional tools available at that location. So we'll close that. And regarding Security Auto Run, look at this. In the registry, under Current User Run, if we select that, it's going to show us what's going to run. Under the local machine, down under shell object. In our registry, there's a key name called web check. So regarding this web check, if we right click, we can delete it right here. We can jump to it inside of regedit, or we can click on properties, look at the properties of it. If we know it's malicious or we don't want it there, we can click on delete and then click on yes to delete it. Now, I would encourage you to be very careful about any changes you make to the registry, because if it's a critical system component or an aspect that's needed, you could be disabling functions or features that you actually want. If we go down to installed components, here we have 5 items, and it has one of them that says suspected malware, which would be a great reason to look further at that and see if it really is malicious. And also across the top, we have tabs for most of these as well, if we don't want to use the menu on the left-hand side. We'd also want to verify that the files and folders that are part of an operating system, for example from Microsoft, we want to verify that they have data integrity, that they have not been modified, that they really are the files from the vendor. And some tools that we can use include SIGVerif, FCIV. Now these are both Microsoft tools, and the FCIV is a tool that creates the MD5 or SHA-1 hash values associated with the Microsoft files so you can verify their integrity. There's also third-party companies that offer services like that. One company is called Tripwire, which, among other security services, Tripwire offers a system integrity verifier, which can scan and then report on the critical files from Microsoft if there's been unauthorized changes or modifications to those files. And one other tool, when we're talking about data integrity for system files, is from Microsoft. That's the System File Checker, and it's another command line tool. So to use SFC, let's go to a command prompt. I'll click on the Windows icon on Windows 10, the bottom left-hand corner, type in CMD, and then right-click on the command prompt and specify we want to run as administrator. We'll say yes to user account control, and we'll maximize that. So from here, to run the System File Checker, we type in SFC for System File Checker, and I'm going to use a /? to have it show you and I the help for this tool. So let's do an SFC /scan now and press enter. It says beginning system scan. This will take some time. It'll go from 0 all the way through 100%. It'll also indicate where the log files are, showing you the results of that scan. Because malicious software is often going to be using and building network connections, besides looking for ports that are in use on the system or waiting for connections to come in, we should also be aware of and look at network activities as well. Because if this is Bob's computer right here, and Bob has some type of malicious software or a worm, maybe Bob's computer is actively scanning looking for other systems. So if Bob's machine has a bunch of half-formed sessions, three-way handshakes that have never completed because there's no services there, or if Bob is making requests out to IP addresses that don't even exist within your internal network, those are all good indicators that there's something malicious going on Bob's computer. Maybe it's Bob the user running an attack tool, or maybe Bob's computer is infected. Also with IP packets, with IP version 4, there are ID numbers associated with packets. So if Bob is sending out ICMP packets, and at layer 3, the packet identifier is always set to 0, that's considered an anomaly. That's not normal. So anytime a protocol is being used in a peculiar or unusual way, that's a great red flag for you and I to jump in and take a look at what's going on with that. we could run something as simple as Wireshark on that computer to take a look at the details of the protocols that are in use, including the port numbers. So if we go back to our Windows 10 computer for a moment, the SFC scan completed. It said it did not find any integrity violations. That's great news. And let's run netstat again, netstat space -a-n. And if we scroll up, we still have this guy in place right here. This is our connection over to the attacker machine. Now, unfortunately, the attacker, which is us in this lab environment, is using port 443. So if we're looking for simply weird or unknown ports, 443 isn't really going to help us that much. But as an example of how a protocol analyzer can help us with this, let's go ahead and launch Wireshark on this Windows 10 computer in our lab. We'll go ahead and select Ethernet 0 as the interface by double-clicking on it, and now it's capturing traffic. So now if we sneak over to our Kali Linux box, which is the attacker machine, and on the Kali Linux box, let's do a show sessions from the social engineering toolkit, and let's type in session-i for interactive 1, which is referring to this session that we have between us and the Windows 10 machine, which is compromised, and we'll press enter. And it says, Keith, you don't know how to type session, it's sessions-i1, and we'll press enter. So now if we type in things like ARP, it'll show us the ARP cache on that Windows 10 computer. And this is really useful information because based on what we just learned from this Windows 10 computer, we know that these addresses, .1, .98, .140, .200, all exist on that local network. And there's the layer 2 addresses associated with them. And then we have some additional addresses, including a broadcast address and also some multicast addresses as well. Now, if we go back to that Windows 10 computer, and I'll bring that full screen again, and we'll stop the capture by clicking on the stop icon. So here in Wireshark, as an example of a protocol analyzer, we could go down to the conversation we're interested in. For example, we could do an IP ADDR == and then the IP address we want to display. And when we press enter, this will display only output where the .109 address is either in the source or destination field in the capture that just happened. So unfortunately for us, it looks like we are not only using the well-known port of 443, but it's actually using encryption based on the output here in the protocol analyzer. So even though we can capture this data, we may never see this as malicious traffic just based on the well-known ports that were used. So if we look at the detail for this individual packet that was captured, at layer 2, here's the layer 2 addresses involved. Here's the layer 3 addresses involved. The source port was 50,639 going to the well-known port of 443. We have some encrypted content here, and we have some more encrypted content here. It's also valuable to note that if we have some destination port, for example, of 6666, we could Google that port, find out if there's malicious software that uses that port, and if the content is not encrypted, we could also look at the content that's being sent back and forth between those two devices. In this nugget, we've taken a look at some methods we could use to discover malicious applications that are at work on our systems. I hope this has been informative for you, and I'd like to thank you for viewing.